Okay, parallel and perpendicular lines. I'm breaking this out in its own video because this is something that always pops up on the SAT at least once. So even if it's been a couple of years since you had Algebra 2 or Algebra 1 or wherever they covered this stuff, welcome back to lines. You thought you'd left them behind. And if you're seeing this for the first time, remember this, because in 2 years you're going to have to come back and check it out before the SAT. All right, so how does it work? Parallel lines are these ones, where it goes in the same direction, never crosses like railroad rails. And then perpendicular is a slightly trickier one. That's the one where they're 90 degrees to each other. So no matter which orientation they're in, as long as they're at a 90-degree angle or a right angle, they're perpendicular lines. And your teacher might even call them normal lines, because for some reason normal means 90 degrees for some mathematic types. But here we go. So the trick is that parallel lines have identical slopes. So 2 in front of the x's. Now remember, the number in front of the x is only the slope of the line if there's a 1 in front of the y. But because both these have sort of an imaginary 1 in front of them, that means the slopes of each is 2. And they have different y-intercepts. If they had both been -3 or 7, then they'd have the same intercept, same slope. They'd be the same line, right? But since these have different intercepts, they're going to cross the y-axis at different spots, but going in the exact same direction. So that means they're just offset a little bit, but they'll never cross. Perpendicular slopes are the ones that are trickier to remember, but it's called negative reciprocal slopes. So in this case, these two lines are in fact perpendicular, because if you took the negative reciprocal of -1/5, you start by making it negative, so that makes it positive, and then you have to flip the fraction. So that's going to go to 5/1, which is 5, which is the slope of this other line. Now going the other way can be a little bit trickier. Somebody might say, hey, what's the reciprocal of 3? It's not a fraction, so how can you flip it? Well, every whole number is actually a fraction over 1. So if you want to flip it, that just becomes 1/3. And then, of course, you got to have the negative in front of it. So 3 and -1/3 would be perpendicular slopes. These are a couple of trick questions I want to throw at you just to show you a common mistake that kids make. The first thing kids forget is the negative sign. So they'll think, hey, 1/2 and 2 are reciprocals, and therefore they're perpendicular lines. But they're not, because they're not negatives. It'd have to be -1/2 and 2. And you can see that if you ever want to graph these things. A slope of 1/2, positive 1/2 is up to the right, but it's a fraction, so it's kind of a gradual increase. And then +2, still going up to the right, but faster. It's more like this. But either way, you can see that these are pretty close. Definitely not 90 degrees. Got to have a negative sign. If one's going up to the right, the other one's got to go up to the left in order for them to have a right angle. If they're both going up to the right or down to the right, then there's no way they're perpendicular. Similar thing happens on this one. If we rearrange it, we'll get we've got to subtract 2x from both sides, so we'll get -3y. Because remember, the slope, standard form that these lines are in, totally meaningless. We've got to rearrange it to have y by itself. So -2x plus 2 for the top one. So divide everything by -3, and we'll get y equals 2/3, because the -2 and -3, the signs cancel, and we get 2/3 x minus 2/3. So that's one line. And the other one, we're going to subtract 2x, so we get 3y equals -2x plus 1. Divide everything by 3, you get y equals -2/3 x plus 1/3. Intercept doesn't really matter. What we're looking at is the slopes. So now that we're in slope-intercept form, the slope of this line is -2/3. The slope of this one is +2/3. And that came from the fact that they had different signs to begin with. But +2/3 and -2/3, just because they're negatives, does not make them perpendicular. And if you graph these two lines, what you would get is that +2/3 is kind of a gradual up to the right, and -2/3 is the same gradual, only to the down to the right. And these are not perpendicular. So, got to be reciprocals. What would be the perpendicular to 2/3? -3/2, because if you flip it and negate it, that's the perpendicular slope to 2/3. All right, let's do the slightly more complicated type of problem. Now, in all those point slope and other videos that you looked at, we figured out how to find the equation of a line through a point, either with a given slope or maybe they gave us 2 points. So this type of problem is very similar, only instead of flat out giving you the slope of the line, they're going to tell you they want the line perpendicular or parallel to the line they're giving you. So the first thing we'll want to do is just figure out, hey, what was the slope of the original? So if the original is -2, and then this is a parallel situation, which means we want the same slope. So our slope is also going to equal -2. And we have a point 2, 6, so at this point we can do it one of two ways. I'll demonstrate them both. One is we'll just plug into the point slope form, which is what I always do, which is m times x minus x1. So I just plug in y minus the y coordinate I've got, which is 6, equals -2 times x minus the x coordinate of a point I've got. And that is point slope form. We could just multiply this out and rearrange it if we wanted standard form or something. The other way to go is y equals mx plus b form. So we'd have to plug in, first step is plug in -2 for m. We still have b, which means now we need to solve for b by plugging in our points. So we're going to plug in 2, 6. So we get 6 equals -2 times x, which is 2, plus b, so this is -4, plus b equals 6. And hopefully you can tell my b's apart from my 6's. Add 4 to both sides, and we get 10 equals b. So now we're going to take this and plug it into here. So we get y equals -2x plus 10. All right, either way we should get the same thing. Whichever way you prefer is great. But I would encourage you to consider point slope form for situations where you've got a point and a slope. It's a very well named form if you ask me. All right, this one's pretty much the same problem, only this time we're doing perpendicular. So the slope of the original problem here is -1. So what does that mean the slope of our line is going to be? That's going to be the negative reciprocal. So what's the reciprocal of 1? Just 1, and then you negate it, so it makes it +1. So our slope is going to be +1. It turns out the +1 and -1 are negative reciprocals. So y minus 6 equals 1 times x minus 2 in point slope form. Of course, 1 times all this stuff, I would just distribute that out. Y minus 6 equals x minus 2. Add 6 to both sides, we get y equals x plus 4. Pretty fun. Now, if you wanted to double check your work, you could plot both of these. This first equation had a y-intercept of 1, and then a slope of -1, which is up 1, left 1, up 1, left 1. So, as I mentioned in my graphing lines video, though, I would encourage you to just plug in points instead of trying to do that up and over thing. And then a slope of +1 is another one I know, so a slope-intercept of 4. And +1 is 45 degrees up and to the right. So you can see these are, in fact, looking pretty perpendicular, so I'm pretty happy with the answer we got. It looks like we got it right. All right, final two problems will be slightly trickier because the original problem is a little bit weird. What is the slope of this problem? Now, when I tutor kids in person, this is what always happens. If we get a weird line, like where one of the letters is missing, their question is, uh-oh, I can't figure out the slope because there's no x. You know, because if the way you always do these is you figure out the slope based on whatever number happens to be in front of the x that x is multiplied by, then if there's no x, you're like, uh-oh, can't find a slope. Well, whenever one of the letters is missing, that should be your tip-off that, hey, this must be one of those special lines, either horizontal or vertical. So which one is it? The way I remember this is that because y equals 1 has a y in it and y is vertical, so I'm thinking it must be a vertical line. But I also know that I'm always wrong about that, so therefore it's horizontal. So sure enough, y equals 1 is a horizontal line. It's a line where every single point along the line, because remember a line is just a collection of infinity points all right next to each other. Every one of those is going to have a coordinate of something, comma 1. So that's why y equals 1 is the equation of a horizontal line. All these points have to have the same y value. So what's going to be a line perpendicular to that? Well, it's going to be x equals a number, right? Because x is the equation for vertical lines. Another way of looking at it is if y equals 1 is my first line, my other one must be the opposite, x equals something. Now what does x equal? Well, if it's going to go through the point 2, 5, doesn't it have to have the x coordinate of that point? Because it's going to be a vertical line like this through that point. Every single point along here is going to have a point of 2, something. 2, 1, 2, 2, 2, 3. So that means all my x values are 2, and that's the equation of the line. Similar thing's going to happen if we start with an x equals number. Now, as we saw a second ago, the perpendicular line, you just switch letters. So the opposite of x equals 7 is y equals something. Not necessarily 7, though. this y-coordinate is going to be whatever the y-coordinate is of the point that the line goes through. So it's going to be y equals 5. If you don't believe me, we can just plot it up real quick and make sure. So I want the equation of a line that's through this point that's perpendicular to x equals 7. X equals 7 is way out here somewhere. And that's a vertical line where all the x values are 7. So 7 comma 0, 7 comma 1, 7 comma 2. So it makes sense that's a vertical line, which means I want a horizontal line. If you graph this one I just got, y equals 5, I think it should look like that. And that makes sense because all these points, this would be like 0 comma 5, 1 comma 5, 2 comma 5, 3 comma 5. Everything has a y-coordinate of 5. So there you go. Y equals 5 looks pretty correct. So that's it. Remember, perpendicular slopes, perpendicular lines, have negative reciprocal slopes. That means we have to flip it and put a negative sign in front. If you don't do that, if it's flipped but no negative sign, or if it's negative with no flip, it's not perpendicular, and that's how they'll burn you on the SAT.